Welcome to Programming in Modern C++. We are in week 7 and we are going to discuss module 33. From the last module, we have started discussing typecasting in C++. In module 26, we had discussed this for C, and what we are taking a look at is in C++, you have different cast operators for specific semantics of casting that you need. And in this context, we have seen one cast operator, const cast, with examples which can be used to remove constness, volatility, CV qualifiers, manipulate with the CV qualifiers of different pointers, references and so on. In the present module, we will continue on this and we will take a look at two other operators, static cast and reinterpret cast. So, this is the outline which will be on the left panel as usual. So, before we get into the meat of discussion in this module, let us just quickly recap what we have seen in the last module, that what are the types of casting that C cast provide us, and why do we need separate specific casting operators for C++, particularly to have fresh inference of types without or with change of value. I will remind you again that C++ is a strongly typed language. Therefore, it is always necessary for the developer as well as the compiler to understand the type of every literal, every variable, every expression, and deal with their conversions casting with lot of care. So, we have seen the const cast. Today, we are going to discuss about static cast and reinterpret cast with the specific context in which they are useful. So, we start with the static cast operator, which is which in a way is a common kind of C equivalent casting in C++ with this operator, which can perform all conversions that are allowed implicitly. Right. So, if something is allowed implicitly, you can write specific typecast operator in that place. We will see examples. It also allows us to do some of the opposite things, like by implicit conversion you can convert any pointer type to void star, but certainly you cannot convert void star to pointer type, which you can do by static cast in case you need to really reassign type to a pointer. You can convert integer floating point values to enum types, you can convert one enum type to another enum type and so on. You have to be very careful always, because when you are doing these things you must know that what you really mean and what you are really doing. Static cast can perform conversions of pointers, pointer types to related classes. Certainly, it can do upcast because it is implicit, but it can also do downcast, though that is not the proper way to do downcast. We will see in the next module, we will discuss about the downcast operator specifically, but static cast also allows you to force a downcast if you really need to do that. But the caveat in that is when it does a downcast, it does not check at the runtime, because static cast, as the name suggests, is at the compile time, is a static time. So, it does not check any real existence of the downcast object at the runtime, and therefore, downcast perform using static cast could lead you to some problems. We will see those examples. Additionally, static cast can do perform conversion based on a single argument constructor or a conversion operator. These will be new concepts which are called user defined cast. It can convert to Rvalue reference, it can convert enum to integer or floating point, it can convert any type to void, that is, do the evaluation and just forget about, discard the value, right. So, these are the different kind of things that static cast is capable of giving us. So, we will start with extending the example of built-in type casting that we had seen in C. This is note I is an integer, j is a long, d is a double, and I have pi and pd and pv as 3 different pointer types. Now, if I cast a double to integer, implicitly it is allowed, we have seen, but it gives a warning. But if I do that with static cast, it will, the compiler will be silent, because compiler knows what you are doing, right. So, you can again get reminded of the style of doing this. Since we are converting, we need to know the expression and its type that is there in the source, and we need to know the target type. So, the type of source does not need to be specified, because once you put the expression within this parenthesis, the parameter of the static cast, you will automatically get to know the type, because it is strongly typed. So, it has a type. So, that is the source type, which is double here, and this is the target type, which is int. So, this style continues. Now, this was from int to double, I am sorry, this was from double to int. The next is from int to double, which is implicit, silent even for that, because it is going to a bigger type, and certainly you can do a static cast for that. You can convert a pointer to void, implicit. Obviously, you can do that by static cast, but you cannot convert a pointer to void to a specifically typed pointer, like pointer to integer here. But using static cast, you can do that. Using static cast, you can do that, and the compiler will be silent. It is okay to do that, which means that compiler understands that if you are converting a pointer to void to, say, a pointer to integer, then you know exactly what you are doing. You can now finally, let us look at the conversion between pointer and integral values. We discussed this at length in module 26. So, if you try to do an implicit cast from, say, pointer to double to long, it is an error. If you try to do it using static cast, also you will get an error, because static cast is does not have a semantics to convert a pointer to a long. Converting pointer to a long is just a bit level reinterpretation. It is not a type level conversion, because these two types are in no way related, in no way they can be used. So, even with a static cast, this is not permitted. Now, in parallel to this, I have also put the C style of casting in every place. In all of these three, if you look at, the C style is possible, but our recommendation is never use them, because they cannot be, they are not safe, they are not cannot be easily searched, and so on. Now, in case of pointer to integral type or vice versa, if you use a C style casting as you are doing here, then this will be okay. But obviously, that does not mean that we are promoting C style casting for this case. We will see there is a separate specific cast operator given known as reinterpret cast, which will make it possible to do these things in a proper way. While you do this conversion, again be reminded, we discussed in module 26 at length, that if you try to cast this in C style to long, it will be okay, but if you try to cast this in C style to int, you will get an error. This is for a machine where the long and the pointer are of size 8 bytes, but int is of size 4 bytes. So, this is a necessity that when we convert pointer to integral type, the integral type must be large enough to hold the pointer. So, that same error will continue, and the take back here is static cast cannot be used for these conversions, and we need a separate cast operator for this, and never use the C style casting. Again relook at the class hierarchy. A is a base class and B is a derived class here. I have a object and a B object. I have an A pointer P and I am setting the address of B, which is a derived class object, which means that I am going from specialization to generalization, and that is implicitly okay, that is okay with the static cast, obviously okay with the C style cast, but we would not recommend it. If I try to do the reverse, if I try to do a downcast, that is take a pointer to the specialized class derived class B and try to convert a object, the generalized object, to that, we have seen several reasons as to why this is not advisable, this is not possible in general. So, implicit cast has an error, which is the perfect way to go. But by static cast, by doing a static cast as in here, you can force this downcast. Again, this is not recommended, because really when you are forcing this down, you do not know whether there is enough information available in this source object, source expression, to evaluate the specialized object, the target expression. For this, we will discuss in the next module another special cast operator called dynamic cast. Obviously, C style casting will work, but not recommended to be used. So, to conclude, for related classes on the hierarchy, static cast should be used for doing upcast. Now, here I will just point you to a little pitfall in terms of a very common mistake that many of us do. Just think about, there is a class window which has a resizing method on resize. If you try to drag and resize the window, this function is called and the resizing drawings are done. Now, from that we have specialized to a special window, which may have some additional requirement when you resize it. So, when you resize, what you would want, that the basic functionality of the resize of the window, the parent class, should be first called, so that the basic resizing is done, and then the extra work that you need for the special window is carried out. Now, naturally for this you want to call this function. So, one common mistake we do is we take the object which is the special window object, that is start this, right, special window object, and static cast it to the window object. So, we say okay, we will static cast, we are doing upcast because we are going up. But if you do that, recall that this will actually lead to slicing, because you are trying to copy a specialized object as a generalized object, right. So, when you do that, you will have only the base part going, and how will the compiler handle that, because compiler cannot lose the original object. So, compiler creates a temporary and slices the base part of the special window object as a temporary window object, and on that it calls the method. It does not call the method on the current object. It is calling it on a temporary which you have created because of this static casting, and therefore, you will see no effect. So, please remember that whenever you work on a hierarchy and you have to call the function of the base or base of base and or whatever, then you cannot, you should never use the way to copy the larger, the derived class object as the base class object by casting. Right? What you should do is very simple, just directly call the base class function window colon colon on resize, just directly call it, so that it is called on the current object, effects also happen on the current object and everything works fine. Right? So, please be careful about this pitfall. I have shown it in the one context of Windows programming, but it is a very general issue to happen. Now, I will introduce you to what you can define as your own casting operator. For example, you have two unrelated classes A and B, they are not related, they are not on the hierarchy. So, as we have seen, any kind of conversion from A to B is error, whether you do it implicitly by C style casting, by static casting, it is an error. Similarly, if I try to convert say int to A, all of these are error. Right? It is as it should be, because they are unrelated, there is no semantics on that. So, what we can do is we can define the semantics for it, because why is this an error? Why converting B to A is an error? Because I have an A B object, I have a B object, and what do I need as a target output? I need an A object. Now, an A object has to be constructed. I cannot get an A object just out of nothing. Right? So, in C++, as you have understood, is I really need an instance of the A object to be created from the B object, only then the conversion has a meaning. Otherwise, what is the result of it? In the built-in type, this is not an issue, because built-in types do not have constructors. They have built-in processes to create the data pattern from int to double or from double to int and so on, but no such thing exists for types that we have defined, the class A and class B. So, very simply what we need is, if we need to convert a B type object to an A type, I need to provide a constructor for that. That is the simplest way of doing it. Just provide a constructor which takes a B object and gives you an A object. As you provide that, all of these will become valid. Even the implicit cast will become valid, because it gets a implicit cast sees that there is a B object, it sees that it needs an A object, and it finds that there is a constructor to allow you to do that. So, it will invoke that constructor. Similarly, you can do that by static cast, which is what I will recommend. C style casting also allows it, though we will not recommend that. Using the same style, I can also do a conversion from int to A, because again what it means, if I am converting an integer to the A object, it means that given an integer, I want to construct an A object, which means a constructor of this form. An A object will be created by this constructor, right. So, all of these again will be correct, right. Even the implicit, obviously the C style, and the static cast, which is what I will recommend. So, this is one way of, so if you are able to edit or able to put code in the target type, here A is the target type. If you are able to edit that, then the way to give a conversion from any source type is to provide a constructor for it. Obviously, these constructors have to be single parameter constructor, because it is to be used for the cast operator. If it has more than one parameter, then the cast operator would not be able to do that quite obviously, because the other parameters will not be known to the cast operator. So, here you see a very nice thing that using the static cast operator, you can actually control the casting logic depending on how you define these constructors. Okay. Let us look at this example in a different way. First part of this, again A and B are the same unrelated classes, is from B to A, which we have already discussed in a certain way. In the second part, what we want to look at is A being converted to int. Right. Now, when you convert int to A, you know how to do it by providing a constructor, which takes an integer, gives you an A. What you do if you have to convert from A to int? You cannot provide a constructor in int type, which takes say A object and gives you an integer, right. You do not have that option, it is a built-in type. Right. Similarly, if you have a situation that where you are not allowed to edit the target type, B to A, how did we do? We just added a constructor in A which takes B object as a parameter, which means I need to edit the class A. Now, if I am not allowed to do that, how do I do it? So, there are two situations. In one case, it is not possible to edit the target class, and in the other case we are assuming that we are not allowed to do that. So, it boils down to the same thing, that if you are not allowed to edit the target class, how do you do that? The way of the path of doing constructors, putting constructors does not work. This is where C++ has given another new another novel operator called the casting operator, wherein in class B we write operator A. The name of the operator is A itself. You can see there is no return type. Why there is no return type? The operator A will operate on a B object and will return you an A type object. That is the purpose. So, you do not need to specify any return type, because the return type has to be an A object. So, this kind of user defined cast operator, written like operator, the keyword followed by the target type, then you just have a parenthesis, no parameter, this is the fixed style, will be used by the static cast or for casting. So, now given this, if you want to do this conversion, even the implicit conversion would be allowed, because it knows that you want to take a B object to an A object. So, what are the choices? One choice is the class A has a constructor which takes B as a parameter, does not exist here. So, that path is ruled out. Second, it checks, does class B has class B provided A as a target type to be converted to. The first one, constructor path, is based on the source type, this is based on the target type. So, given B, it has given an operator, user defined operator for the target type A. So, the types match and it will invoke that operator. Implicitly it will happen, by static cast it will happen, by C style casting it will happen. We will again always recommend that you use the static cast on this. Similarly, if you want to convert say A to int, since you cannot do it based on the target type, you have to do it based on the source type. So, on A you provide a casting operator, operator int, where the target type is int. So, you will, if you provide that, then this conversion will be allowed in all of these cases. Again, you do not need to give a return type, because it is known that the return type has to be an integer. So, you may note that in both of these operator cases, the return will always have to return the object of the target type. Right. So, here you have to, now here I have just directly shown that as if this constructor is getting called. You can have a whole lot of logic to construct that object, but the end of it, it has to return an object of type A. Here it has to return an integer, because you are converting to int. Right. So, two pathways. Now, if both are available for a conversion between two classes, two types, then obviously the compiler will get confused and the compiler will not know which one to use, and you will have error. Right. So, you have to choose which one you want to do and write the expression in a different form. Next, we look at the reinterpret cast. We already mentioned that reinterpret cast is a very special type of cast operator, which is given where static cast cannot work. So, reinterpret cast basically works in two contexts. One is to convert one pointer type to another where there is no relationship at all, or between a pointer type and an integer type. So, these are the two contexts in which reinterpret cast will work. Unlike static cast, where you can see that actually computations are being done, functions are getting called, you can implement logic internally. Reinterpret cast is not like that. Reinterpret cast simply takes the binary copy of the source value and thinks it is the target value. It is just that. So, it just erases the source type, puts the target type. Right. So, all pointer conversions are allowed in terms of reinterpret cast, but it does not take cognizance of any of the pointed content or any checking on the pointer type or anything of that. Naturally, given this, since it is at that low binary level, the format in which say integers will represent a pointer, particularly if you are doing between integer and pointer, is platform specific. We have already seen examples in module 26 that I could convert between a pointer and long, but could not convert between pointer and int. But if I have a machine where the pointer and int have the same size, I will be able to do that, and that is what is being emphasized by this point, that there is a type defined in the library called intptr underscore t, which gives you the size of the integer that must be provided to fit the pointer type. Right. So, for our earlier case in module 26, this size was 8 bytes. Right. So, these conversions can be performed only by the reinterpret cast, not by the static cast at all. Even as you can do them using C style casting, but never do that, because that is going to be very risky, and you, because this is a C style casting like this one, taking a pointer to an integer, is a significant deviation in terms of the type system, and therefore, it is very important that it stands out boldly in your code. So, the way to do that will be to use reinterpret cast. Naturally, the implicit casting does not work. Similarly, for two unrelated type pointers, the implicit cast does not work, but reinterpret cast will work. So, these are the two contexts where you should use reinterpret cast. And a word of caution, a lot of survey has been done on community code basis to check, do we really need a reinterpret cast? The answer is no. It is usually, this is the only case where, if you are doing that kind of programming of serialization, deserialization, stuff like that, is the only case where you might need reinterpret cast. So, maybe in a very huge program, there may be one instance of reinterpret cast, but if usually this will never be needed if you have done your design correctly. So, if you are requiring reinterpret cast often, then ask yourself, there must be something wrong in the design. It is not good to erase types and put a different type to fool the compiler, because in turn the compiler is your greatest friend in programming. So, if you fool the compiler, you are actually fooling yourself. So, avoid using reinterpret cast as much as possible, and always question if you are using it, and make sure that your design and the context are correct to use that. So, in this module we have studied static cast with all its different nuances. Particularly, we have taken a look at user defined cast operators in terms of constructor, single parameter constructor, as well as user defined cast operator type, and we have seen how reinterpret cast can be used in specific context of type erasing and redefinition. Thank you very much for your attention. We will meet in the next module.